Okay, so the next thing we would like to talk about is FastText, and for language model, because it is a little bit complex, and we have some other more complex model, right? So basically, we don't write language model by ourselves. We simply just use some convenient package to help us to convert text into vertex. Okay, so into vector. So fast text is one of the nice Python packages that help us to do so, and we would like to show you the tutorial of this fast text. Okay, and before that, fast text has two different mode. Okay, the first one is supervised. The other is called unsupervised. But actually, here I'd like to show you the structure of its proposed method. Okay, the first one is called supervised. So basically, when you perform fast test, try to transform your text data to vector. For supervised mode, you have to provide label, and that it should be classification labels. So for example, maybe you have some corpus, okay, and maybe from some tails, okay. So some of them are magic tails, some of them are animal tails, okay. So before you perform such kind of transformation from text to vector, you have a specific downstream task. For example, tail classification. Okay, so it's either magic or either animal. So you can use this specific text to help you to transform your data to your text data to numeric data. So right here we have some tokens, right? You have a corpus, you have tokens, and you have a dictionary, and you can transform your text to one-hot encoding. So after that, the fast test, okay, it has certain predefined neural network, okay, and again, in this neural network, it has a vector, it has a weight, okay, W weight, which simply what we introduced in word2vector. And after that, it attached a built-in classifier to classify your result to certain downstream classification. For example, tail classification is either magic or animal. Okay, you have to provide a classification when you perform such kind of supervised learning in fast text. Okay, so that is one of the way. The other way the other method is called unsupervised, but I do not agree to use this word unsupervised, so I rather to call it self-supervised. So it's very similar to it's basically it is closed test. So it's very similar. We have tokens, we have dictionary, and we use one-hot encoding to represent the word we have, and we have a neural network, and it has a weight right here to be optimized. And after that, it output a dictionary. It output a softmax value to perform a specific built-in task, which is closed test. It's very similar to the previous one, but the previous one you have a specific downstream task to perform. But in this second method, self-supervised learning, it performs closed prediction. Okay, so for the second one, for the self-supervised one, you don't have to provide any label. The only thing you need to provide is your corpus. Okay, so let's take a look at how it works, how code are written by FastText. Okay, we have two example right here. The first one is supervised text classification. Second one is unsupervised, but I don't agree this word. Okay, it is self-supervised, the word representation. So firstly, we take a look at the first one is text classification. Okay, as mentioned, okay, you have a document, and you have to assign this document to one or multiple categories. Okay, to for example, for cybersecurity, you can given a email. Okay, we can perform spam detection. Okay, given given a log, we can perform intrusion detection to specify if it is a log which record the intrusion, or we can detect if this email is a spam mail or it is not not a normal mail. So we have a specific downstream task, and we have the label so that we can use FastText to perform such kind of classification. Okay, so again, you can install this by pip install. Okay, so here's the manual. So we skip the manual. Okay, we simply just take a look at the data, and you can see that it downloads certain data from the public available place. Okay, and you can see that okay, it is data set. Okay, take a look at this one. Okay, here we have a label, right? You see that dash underscore underscore label underscore underscore. Okay, in FastText. Okay, when you prepare the training data, okay, the corpus should be a plain text file, and every line in that plain text file is your training data. Okay, but the first word is your label when you perform such kind of supervised learning, and the label should start by underscore underscore label underscore underscore, and you put the label after this prefix, and after that is your text. Okay, so I think here is we have example right here. So right here you can see that you should prepare plain text, and the first word should be something like this: underscore label underscore underscore bacon. So the bacon is the label name. Okay, the bacon. So after that, you provide the text. So the text right here is which bacon dish is best to bake a banana bread? Question mark. So that is one line. So in your training data, you should have lots of lines in this format, so that FastText will use the first word starting with underscore underscore label underscore underscore, and the name baking as its training data, training label, and the input text X is the word, is the sentence behind it. Okay, so it's very simple. In this example, we can see that we have about 15,000 lines. Okay, so each line, so it separates the corpus. The training data has only 12,000 lines, and the validation data has 3,000 lines. And each line, it has a label and its corresponding text, input text. And FastText will use its built-in neural network to encode the text, to build a dictionary, to perform one-hot encoding, to perform neural network, to perform softmax, and to add an additional classifier after word embedding to perform label classification. Okay, so you simply just use train supervised, and you give this function all your training data, including the label, including the text. So as you can see that it has 14,000 lines, and amazingly, it has 734 different labels. So it's quite a lot, right? So After this very simple line, train supervised, and the neural network has been trained. So you can save the model, you can load the model, and you can input new sentence to predict which label it should be. And as you can see, this which baking dish is best to bake a banana bread. Okay, its output, its classification result is bacon, label bacon, and its softmax value is 0.15. Okay, so the next prediction, why not put knives in the dishwater? So the prediction label is food safety, and its corresponding softmax value is 0.08, and so on and so forth. So you can even use a model test to test the entire data set. So we have 3,000 lines in cooking validate, right? So the corresponding result is 0.12 and 12% and 5%. It's corresponding to its precision rate and recall rate. Okay. So again, there are some advanced usage to in this package. For example, K. The K stands for, since it is a classification problem, right? But in this case, it has 700 labels, right? So it is very difficult to find the correct label, correct category. So sometimes the K equals 5 right here, it means I like to show the top 5 softmax value and its corresponding label. So the why not put knives in the dishwater, K equals 5, that means the top 5 softmax category is food safety, baking, equipment, and blah blah blah. So sometimes, yeah, we can do so to see if it is matches to our result. Okay. So of course there are some other parameters can be used. For example, as we mentioned, it would be better to perform some pre-processing before you input your data into language to train a language model. So right here, again, it seems like it removes the punctuation and use lowercase. Okay, and after that, you can see that the after you use the lowercase word and you remove the punctuation, and you can see that the number of dictionary decrease it apparently, right? And it makes the precision rate go up by 4%. So it really does matter if you perform appropriate pre-processing. Okay, and of course you can use more epoch to train the model, right? And of course you can use your learning rate right here. You can design different learning rate. So after that, you have your own. You design different epochs. You have different configuration of a learning rate. Maybe your precision and recall rate may increase. Okay. The next thing I want to talk about is the n-gram. Okay. So that means when we build a dictionary, okay, each word will be each vocabulary will be one word in the dictionary, right? But that is 1 gram. If you choose 2 gram, that means we like to preserve some short-term relationship of the words. So for example, right here, why not put knives in the dishwater? You can see that there are 7 words in this sentence, right? So basically, we have 7 words in the dictionary, right? But when you use 2 gram, that means we view y and not as one single word in the dictionary. We concatenate 2 words as one word when we perform 2 gram. So why not is a new word in our dictionary. Not put will be a new word. Put knives will be a new word. Knives in the dishwater will be new words in our dictionary. So in this case, we can preserve some short-term relationship between this word. But as you can see that if you perform 2 gram to analyze your data, okay, and your dictionary will, the size of your dictionary will increase, right? Because originally in this word, in this sentence, we have only 7 words, but why not become, for every pair of words will become a possible word in your dictionary. So your the size of a dictionary increase. But it's sometimes it really works, okay? So if you use word n-gram equals 2, so the dictionary changes, okay? So maybe that makes your classification result a little bit better. Okay, there's some explanation of bigram. Bigram means 2 gram. Okay, so make sure you take a look at this these paragraphs. Okay, so if you use nice computer, you can use different loss function. Okay, there's some explanation right here. Then last thing I would like to talk about is multi-label classification. In previous classification problem, we have only one class, right, to predict. But sometimes you may want to perform multi-label classification, which means you have more than two outputs in your Y. For example, if there is a movie review comment, okay, and for classification problem, the review result might be I like or I dislike this movie. So you choose between 2 categories, right? But for multi-label classification, maybe the result is if it is a scare movie, it's a science fiction, or it is a movie for children, or it is a comedy, or if it is a drama. It is a multiple choice, right? You can select a multiple label in your classification. So if you want to do so, if your data is multi-label data, and you can simply just use the right here, okay, loss, okay, OVA or 1V versus O, okay, to analyze your data. So after that, when you perform prediction, it will predict several different results. I mean several different labels for you. So for this example, if you use multi-label, so which baking dishes is best to bake a banana bread? Okay, so if you have a threshold right here, maybe you can output 2 different labels. So first one is bananas, the other is bread. Okay, so I wish you can take a look at this document and try to run your to analyze the text to perform text classification. Okay, that is the first method, supervised learning, and the other one is very similar to word embedding, which is called word representation. Okay, so again, in this case, in this example, it downloads some paragraph from Wikipedia. Okay, so For example, okay, that is one of the example. One of the line, okay, something originate as a term of abuse, something. That is a lot of a lot of words in this corpus. Okay, so it's very simple because it is just like Hsiao and Skitgram. You don't have to do anything. Okay, they FastText already designed the neural network, already help you to build the dictionary. You simply just use train unsupervised and give this function the training data, and after that, okay, the result shows that, okay, we have a dictionary right here, and we have the get word vector function to help you to get the word embedding result right here. You can save the model, you can input the model. So it's just like what we show you, okay? And FastText implement Skitgram and Hsiao, okay? So you can use Hsiao or Skitgram as the parameter in train unsupervised function, okay? And after that, and again, you can design your network. Okay, for example, right here, dimension 300. That means the yellow weight, okay, it has 300 dimension. So each word has 300 dimension vector. Okay, so right here we have a minima size and maxima size. Okay, that means the subword are all the substring content in word between minima size and maxima size. Okay, take a look at the document. Okay, so again, we can have epoch, we have learning rate, we have thread. So it's very similar to the previous one. So after that, we can print the work vector after training. Okay, we can print the vector of each word. Okay, and there's something very interesting is that it provides a new function called a get nearest neighbor. So it also help you to print out the neighboring vectors and its corresponding word. It's quite useful for some application. Okay. The next thing is that as you can see that we have I will show you right here. Okay, as you can see that after we perform the word embedding, maybe there is D1, D2, and D300. Okay, so on and so forth. Okay, and we have some words right here, right? And for every word, you can see it as vector. So basically, after people perform Hsiao or Skitgram, they found something very interesting. That, okay, if you take a look at man and woman, there should be two vectors in this 300 dimension. Okay, but you take a look at these specific vectors, okay, which is man minus woman, this vector. Okay, think about something. What is the man minus woman? That means gender, right? That means this direction, they may have certain meanings which is related to gender or sex. Okay, so they want to examine the thing. So they think about another thing is king and queen. If these two vectors, okay, indeed very similar, then that means that the pink one it indeed represent a concept called gender or sex. Okay, but it is not necessarily always true, but some people believe so. So in this case, okay, let's go back to this one. Okay, there's one interesting thing called get analogies. So take a look at this one. Berlin is the capital of Germany, right? So there should be a vector. You can minus German, minus Berlin to German, and you use this specific vector, apply it on France. So the result should be its capital, which is Paris. So it shows that it indeed is Paris, and so on and so forth. You can test it by yourself, but it is not necessary such kind of relationship always valid. Okay, but it is just some interesting things, okay, in word vect. Okay, so again, you can use n-gram to do so, to perform these things. Okay, that's it. FastText is a very simple package. Okay, so you can prepare your corpus, you can prepare your labels to perform word classification, and or you can use simple just, if you don't have corpus, okay, you can simply just use FastText to perform word embedding. Okay, so I'd like to show you something in Orange. Okay, Orange also has some interesting things. Okay, let's take a look at okay, so we have a corpus right here, and we have a corpus viewer. So let's take this one. I think that is the green tails, right? That is green tails. Okay, so green tails has a content right here, and it has a classification. So it is either Tales of Magic or Tales Animal Tales. Okay, two different classes. So again, in the previous we can use a preprocessing right here, so that this preprocessing will help us to remove all the punctuation and to make it the lower cases. So you can take a look at this configuration. So after that, we can perform backup words. Okay, we talk about backup word. It simply just count how many different words in this corpus. For example, for this tale, okay, a tale about a boy who went forth to blah blah blah, and you can take a look at the content right here. Right, it's a very long content, and you can see that after backup word, we can count. Okay, in this tale, we have one able, one accord, one actual, one afraid, one ago, and 7 are, one air, and so on and so forth. So that is a very big table, okay, to record all the occurrence of frequency of each word. Okay, so since we have this table, we can perform any classification. For example, we use a very simple SVM right here. So as you can see that we can perform a classification of this tale by using this very simple counting the frequency of occurrence of each word. But as we mentioned, when we count this word, we simply just lost the information of sentence, because it's just simply count words, right? So we don't know what word is behind or in front of afraid. It's simply just count word. But but sometimes it really doesn't matter, because in these cases animal tales and magic tales, they simply just use different sets of words. So if you perform such kind of analysis, it's okay. Okay, you know, it takes time. Okay. While trying to do so, okay, the other thing that I would like to introduce is called document embedding. Because we have bag of word, right? We have another interesting thing is that it has a built-in FastText. So basically, it uses skipgram on English word. Okay, so after that, you can simply let's take a look at this one. Okay, if you use a bag of word to perform classification, and you can see that the classification rate is not that good. Okay, it's not that good. But if you use the document embedding, which means you use Hsiao or skipgram to perform classification, to perform word embedding, and you can see that again, it will output 300 dimensions right here. So every word in the corpus in this tell, in this content, each word right here will be present as a 300 dimension vector. But you know, as you know, a tell has a lot of words in it, right? So as you can see that, how do we aggregate those words? And here, the aggregator means right here is mean. That is simply just average every word it used in the tell. No matter it has 1,000 words or 2,000 words, it simply just do average. And as we can see that it's still okay because we have the numeric data. So we can use this numeric data to perform classification, right? We can still use this 300 dimension to perform classification, right? So here, and we still use, for example, SVM right here. And as you can see that the classification rate increased because we believe that using FastText, using Hsiao and skipgram to represent the data, text-based data is much better than using a simple bag of word. Even though that aggregator is quite is not that good, it's very a simple one. Okay, and we will talk about BERT next hour. Okay, and we can use Orange to perform BERT. And again, since you have the embedding result, right? And you can perform anything you'd like. For example, we can perform hierarchical clustering right here. So we can see that we have several different tails, and you can see that animal tails are quite close with each other. They can group cluster firstly in this cluster. And of course, there's some other magic tail, for example, the red one. Snow White is a magic tail or it is an animal tail. It's depend on the people who label it. So the word used by snowmare is quite similar to some other animal tails, because I think there are some other animals in Snow White. Okay, so that you can do so. So after that, after word embedding, you don't need to deal with text anymore, because after embedding, you simply just you simply got the numeric vectors. And of course, right here, the aggregator use average as the aggregator is not a good way. But if you would like to use a more complicated or complicated model to aggregate different words, you can use RNN, recurrent neural network. or you can use BERT. We will talk about it later next hour. Okay, we stop right here.